Good afternoon, everyone. We're going to go ahead and into our third installment of our video, looking still at properties of matter. And now that we understand how the states of matter sort of look, we know how to analyze and see different chemical and physical properties. Now we're going to look at how matter itself is organized. Now, our goal for this video is going to be that by the end, I want you to be able to distinguish between the different types of matter and give at least 3 examples of each. Okay? So, let's jump into it. Now, the first category that we're going to look at for organization of matter is pure substances. Now, when you think pure, you think things that have nothing mixed in. So, the first one that we're going to look at is our elements, or our elements. Now, these are what we look at on our periodic table. All those different substances that we found over time. A lot of them in Earth, some of them are man-made. Now, one of the main characteristics of elements is that they cannot be decomposed or broken down into simpler substances without losing their properties. So, if I have an atom of mercury, that's as far as I can go. If I break it down any further, it's going to lose the properties that it has. Now, most of our elements are going to be metals. Some are nonmetals, and some are semi-metals or metalloids. When we get to our unit, or as we get closer to our unit on our periodic table, we'll actually start to analyze the periodic table and see where these different points are. Now, if you are looking to figure out if it's an element or if it's a compound or so forth, elements will usually give you a clue. Usually it's going to be a capital letter by itself or a capital letter accompanied by a lowercase letter. So this would be like Hg, like you see here for mercury. Capital H, lowercase g tells you that it's an element by itself. Now, this is just a diagram showing us the periodic table and where each of these different parts are located. The other type of pure substances that we'll come across are compounds. We say that compounds have definite composition, and they're usually made of 2 or more elements. This word definite, we've heard it before when we talked about definite volume and definite shape. It means something that is set, something that can't be changed. We're looking at our compounds for things like NaCl or CO2 or H2O. Each time that I have either of those compounds, they will keep the same formula. Now, you may be thinking, Mr. Baldwin, if it's sodium and chlorine, isn't that a mixture? But one of the things that you'll note is, if you look at the picture here on the side of the actual salt, all of these crystals have the same exact formula. So even though it is sodium and chlorine put together, the fact that all of these crystals have the same composition lets us know that it is actually a pure substance. Okay? Now, these can be broken down into simpler substances by chemical means only. So I can't physically break them, boil them, or anything like that. But if they go through chemical reaction, then I'll be able to actually break them and form something new. The next thing we're going to look at is our mixtures. This is the second category. So pure substances was first. Now we're moving on to mixtures. And mixtures are just matter with changing compositions. Anything that you've ever thought of when someone makes cake batter or cake mix, or macaroni and cheese or pizza, these are all mixtures. What makes them a mixture? I have all these different things that are coming together, and they keep their property. If I make a pizza, I have my cheese, I have my sauce, I have my crust, I have whatever other toppings you want to throw in there, and they all remain just as they are. There's no chemical reaction that changes them and gives them any other properties. A tomato will still taste like a tomato, an onion will still taste like an onion. Now, if we look at our different types of mixtures, now we're going to break it down into 2 categories. The first is a heterogeneous mixture. When you see this hetero in front, right here, hetero means different. So, if it says it's a heterogeneous mixture, that's the way of saying that there are different layers or phases. In other words, I can see the different parts that actually make it up. Examples might be Italian salad dressing, blood, and trail mix. Now, you may be saying, okay, Mr. Baldwin, when I cut myself or scratch myself and I see blood, it looks like one solid liquid. But if you look here at our diagram, you see that it's actually made up of our red blood cells, our white blood cells, our platelets, and there are so many different things that are also mixed in there. So you want to make sure that you pay attention to the type of mixture that it could be. Last but not least, trail mix. Now, although I'm giving you examples here, I want you to come up with your own examples to bring to class. Okay? So, I should not see any of these 6 that are on screen on your paper when you come in tomorrow. Now, the other type that we're going to look at is what we call homogeneous mixtures. Now, if hetero meant different, homo means same. Okay? And these are what we will also call solutions. These have no layers or phases. Or, when you look at it, when you mix them, they all remain uniform. So if I make Kool-Aid or lemonade, I mix in the sugar, I mix in the powder into the water, and I can't tell where the sugar stops and the Kool-Aid powder begins. This is a homogeneous mixture. Some examples include vinegar, which we've seen before we use for our labs, Kool-Aid, some people enjoy drinking, and steel. It doesn't have to be just a liquid in order to be a homogeneous mixture. Steel, when everything is blended together, you can't tell that there's nickel and iron and many times carbon and other things that are also mixed in there. It all looks consistent and uniform. So, just to sum everything up, we have our matter, and underneath that, we have our 2 different areas. Mixtures, if we can change up the composition of it. Pure substances, if it is set and can't be changed. For our mixtures, if we can see the different parts, it's heterogeneous. If we can't, homogeneous. For our pure substances, if it's just one set of atoms, then we say it's our elements. If it is not, if it's multiple or it's a mixture of those atoms bonded together, then it's our compound. And again, remember, chemical methods only. That's the only way I can actually break down our compounds. With that note, I'll leave you, and you have a great evening. Feel free to rewind or write any questions you may have so that I may answer them in class. Have a great evening.